today's lesson is why is the coastline different shapes? As part of this, we need to be able to think about the shape and characteristic of the coastline and to be able to describe those shapes and characteristics. And as part of this, we also need to be able to consider how geology affects the shape and characteristics of that coastline. First of all, look at the picture on the page and think about why this coastline may be eroding. What can you see in the picture that maybe give you some clues as to why this house may have fallen off the cliff and why this process may have taken place? Okay, hopefully we have a look at the picture and we can see that this particular coastline is made up of what looks like a very sandy material, which has probably led to this cliff collapsing along with the house and the other properties in the background. Okay, so here we've got the Geography GCSE specification. So as you can see, today we're mainly focusing on how geological structure and rock type can influence coastal forms. As this is in the specification, you could be asked a question relating to these words in your exam. In front of us, we've now got 7 pictures of 7 different rocks. What I would now like you to do is to spend a couple of minutes thinking about how resistant these rocks might be. I'd like you to write down in order the resistance of these rocks. So which rock do you think would be number 1, the most resistant? Which one would be number 2? And eventually down to number 7, which do you think will be the least resistant? So pause this for a moment and try and write down your 7 rocks in order from most resistant to least resistant. Okay, so hopefully you've got your list sorted. So in positions 1 and 2 should be the most resistant rocks. These should include granite and basalt. These rocks are very, very hard. They are igneous rocks, been created through volcanic activity. Next, in positions 3, 4 and 5 would be our sedimentary rocks, such as sandstone, chalk and limestone. These rocks have been made by the process of dead material falling to the bottom of the sea. That is bits of dead animals and dead plants. Over time, they've been crushed and squashed together to create sedimentary rocks, which is why if you ever look at a sedimentary rock, you find it made up of lots of layers, and also you can see fossils, the remains of sea creatures and plants in them. Finally, we have the weakest sedimentary rocks, such as clay and shale. These will erode very, very quickly and can often be broken just by your hand. So the sea would take very little effort to break these particular rocks up. Okay, so we've now got in front of us a map with lots of colours on it, which is a geology map. It shows the makeup of Great Britain in terms of the types of rocks that are found in the ground. So on your map, what you now need to do is you need to annotate, that is, add labels to your map to try and explain where you think there is hard rock and where you think there is soft rock. So with hard rock, we'll obviously be thinking about things that are resistant. They're going to be able to withstand erosion from the sea. And soft rock is going to be much, much easier to erode and therefore would have been worn away by the sea. So spend a few minutes adding a few labels to your map, a few arrows pointing to certain parts that you think may be made up of hard rock and things that you may be made up of soft rock. So now we understand about different types of geology, we can start to think about the landforms that may have been created. On the slide in front of us is a very simple diagram showing a piece of coastline that is made up of less resistant rock and resistant rock. Some of it is sandstone, some of it is clay, some of it is limestone. First thing I'd like you to do is I'd like you to draw a version of the diagram that's on the slide on the left-hand page. Make sure you label it with hard rock and resistant rock. After you've completed that first drawing, I'd then like you to, next to it, on the right-hand side, draw a diagram that shows what this coastline would look like in the future. Spend a couple of minutes doing your drawings, and then when you're ready, unpause the clip and see whether you got the idea correct. Okay, hopefully your diagram may look something like the one on the right hand side, where we've got resistant rock, which is now jutting out into the sea, creating what we call a headland, and we've got more less resistant rock, which has been worn away and has created a bay with a small beach on it. Obviously, the rate at which this happens would depend on how resistant the hard rock is and how weak the less resistant rock. In some parts of the country, this might happen quickly. In other parts of the country, this may take hundreds, if not thousands of years to get to this position. Unlike the diagram we've just drawn, though, not all parts of the coastline are exactly the same. On the slide in front of us, we've got an example of Dorset in southern England, and it's showing that the rocks are running parallel to the coast. This is going to create a different sort of coastline than if we were just made up of bands of hard rock and soft rock, such as can be seen on the eastern side of this piece of coastline. Where there was soft rock, we've got Swanage Bay, and where we've got hard rock, we've got Durston Head. Obviously, along the southern coast, where the limestone is made up, we've got a very different sort of coastline. What these coastlines are known as are discoordinate and concordinate coasts. The diagram that you drew earlier was known as a discoordinate coastline. This is made up of both hard rock and soft rock and is usually at right angles to the coast. The picture in the bottom left-hand corner is a place called Swanage in Dorset, and you can see the bay with the sandy beach that's been created as the softer material has been eroded, leaving the headlands to stick out in the background. On the right-hand side is an example of what can occur at a concordinate coastline. This is where the rock is made up of material that runs parallel to the coastline. In this case, limestone has been eroded and it's created Lulworth Cove, which is the picture you can see in the bottom right-hand corner. Due to the geology of this coastline, we end up with very different sorts of landforms. In some places, we get headlands and bays, and in other places, we can get features like Lulworth Cove. So, you have a diagram like the one below, which you now need to label with the names of the different coastlines, showing the features that you may find on this type of coastline. Pause this while you complete your diagram. Okay, you should now have something like this. Have a look through your annotations on your map, see if there's anything from this slide that you feel you could add in order to improve your diagram. Remember that a key thing that you need to think about in the exam is having specific detailed information. So places like the names of headlands or the names of bays or whereabouts in the UK these examples could be would be really, really useful to show that you understand and to make use of when answering an exam question based on this topic. Now you've looked at how Lulworth Cove is formed, watch the YouTube clip on the right hand side to understand more about its formation. Start it at 2 minutes 20 and watch until 4:25. The coastline, though, is not just created because of geology. There are other factors that are going to affect it as well. Wind is one of those factors. In the UK, as we've seen many times in our geography lessons, the prevailing wind is from the southwest. That is where our wind comes from most of the time. And for most of the time in the UK, around 80% of the time, our wind blows in across the Atlantic from the southwest. This has an influence on our coastline. To understand a little bit more about fetch, watch the YouTube clip on the right hand side from 52 seconds to 2 minutes 08. This will show you how fetch from the southwest influences the UK. As you can see from the slide, the wind could blow completely uninterrupted across the Atlantic from South America. So wind that blows across this ocean is going to create some very big waves. When those waves arrive in the southwest of England, in places like Cornwall, the fetch that's created them will be making these huge waves. Whereas on our east coast of Britain, the fetch is much smaller, as can be seen by the green arrow. Wind blowing from Scandinavia is not going to be able to create such big waves because it simply won't have blown such a long distance. So the key term here, which we need to make a note of, is the fetch is the length of water that wind blows over before it meets the coast. This map shows the idea about how fetch is influencing different coastlines around the UK. So, using the map, you need to write down, in the UK, the longest fetch is. Looking at the map, where do we think we have this longest fetch? So, from the northeast, looking at our map, obviously the wind blowing from this direction would be less than 500 miles, whereas a fetch coming from the southwest would be well over 3,000 miles out to South America, as we saw in the previous slide. However, while fetch is one thing affecting waves, there are other things that are going to affect it as well. The strength of the wind is going to be another key factor. If the wind is blowing very strongly, this is going to create bigger waves than if we've got a gentle wind. Also, if the wind has been blowing for a very long time, this is going to travel across the water and create big waves, whereas if the wind has not been blowing for a particularly long time, the waves are not going to get a chance to build up and to be as big as if the wind had been blowing for a smaller amount. So fetch, the length of distance the wind blows over, is very important, but also is the strength of the wind and also how long the wind has been blowing for. Finally then, you now need to answer these three questions. Why are some waves bigger and stronger? Think about what we've looked at in this lesson. If you need to, recap through it and then answer the three questions on the slide.